Yep, I hope we are live right now. We will wait for some 2 to 3 minutes for more people to join in. Okay, so people have started joining. Hi, Viraj. Okay, so how are you guys doing? Please let us know in the chats. Okay, so we will wait till 7:05 and then we will get started. Okay, so I guess we can start with our today's session. Let me share my screen and let us know in the chats if my screen is visible. I hope my screen is visible right now. Let us know in the chats whether you can see my screen. Yep. So yeah, let's get started. So hello everyone. Welcome to our third session of Android Study Jams by GDSC VIP. So I hope you guys have been there for the last two sessions and you have learned something interesting. So we are going to learn a lot of new stuffs today, and this is our third session for Android Study Jams, and today we will be looking at coroutines and getting data from internet using Retrofit and showing images using Coil library. Yeah, as we have been discussing throughout this program, we are following this course, Android Basics in Kotlin course, which can be accessed via this link. And I hope by this time you guys have covered most of the units. And after completing all the 6 units, you will receive all these badges in your Google Developer Profile. And we will be sharing a form soon to fill in your Google Developer Profile URL, and that's how we are going to track whether you have completed all the 6 units. And also you can submit your app there, and by submitting an app you will be eligible for cool swags from DSCVIT. And so we will be sharing the form pretty soon, and to get the form, make sure that you have joined this Telegram group. We will share the link once again in the chats, so make sure that you have joined the Telegram group. Also, make sure that you use the concepts that we have covered through this course, through the Android Basics in Kotlin course, all these 6 units. You can use the concepts learned through this to build the app. Of course, the app should be in Kotlin, and you will be eligible for some cool swags when you submit the app. So yeah, also you have to submit your Google Developer Profile URL and make sure that you have completed all the 6 units. Yep. So let's move on. I hope you have joined this group. I will share the link in a few moments. Cool. So this is the plan for the day. First up, we have coroutines, where you will learn how to use coroutines to achieve multitasking in Kotlin. Then we will look at into the introduction of HTTP and REST. And finally, we will build a Mars Photos app where we will be using Retrofit to get data from internet by calling an API. And we will use Coil to display images from internet inside your application. And we will be using Recycler View, which we covered in the last session. So that knowledge will be helpful for you in this particular application that we are going to build towards the third part of today's session. And first thing is coroutines today, and for covering coroutines, we have Ritik Jain from GDSC VIT, who is a senior developer and a full stack mobile developer who has a lot of experience in native as well as cross-platform technologies. So he will be taking coroutines for today, and make sure that you clear all your doubts by posting it in the chat section. We will be there to help you out. I welcome Ritik to take over the session. All the best, Ritik. The stage is all yours.
Yeah, hi guys. I'm Ritik, and I'm currently a third year student in VIT, and I've been doing Android dev from the past 2 years. So looking forward to share my knowledge with you all. I'll be sharing my screen now, and let me know when it's visible. Yeah, it should be visible now. So now, as Jeevan told, I'll be taking the coroutines and concurrency part. First, before we even get started with concurrency and coroutines, I would like to get to know an idea of like what do you think about concurrency? What comes to your mind when someone mentions concurrency? Like, let me know in the chats below. Like, what do you understand by the term concurrency, right? And then we'll move on. I'll be checking out the chats, so be sure to drop something in the chats. I'll give you guys like 2 minutes. And I'm hoping to keep this session totally interactive so that keep dropping in your queries or any doubts you have in the chats, and I'll keep answering them. So Sahil is saying it's same, equal. That's not exactly concurrency, but okay. Yeah, so Rudrank said happening at the same time. That's much more closer to the definition of concurrency, and that's a really good answer. Any more answers? Let's wait for a minute. Okay, so I think those were the answer, and they're pretty good answers. So now the what we mean by concurrency is something happening at the same time, or something which gives us a sense of parallelism, right? And its concurrency is a very important tool in modern day programming, because like all our laptops have multiple cores and each core has multiple threads. So to utilize the benefits of them, we use concurrency. So now, why do we even need concurrency? So like all the apps you have been making in Android, and everything you have made up till now has been executing on the main thread. I've used the term thread, but I'll come back to explaining more about threads in a while. So what I mean by the main thread is that in Android there is a default thread called the main thread, and all the UI updates that are taking place are happening on the main thread. So if you perform a computationally intensive task on the main thread, that is likely to make your UI stutter. So like all our modern day phones, they have to refresh at the rate of at least 60 frames per second, or nowadays even 90 or 120, right? That's the screen refresh rate. And that many times Android has to actually display the frames in a single second. That's already a lot of work. And if we add more work on top of rendering the UI, it's obviously going to slow down the process of rendering the UI, which is the main function of the main thread. So we can't let that happen, right? And that is where we introduce the concept of threads or concurrency or coroutines in Kotlin specific terms. Now, let's understand this with a simple diagram. Now, what has been happening till now is single path of execution. So first, the task one is executed, then task two, then task three. But when we get into concurrency, what actually starts to happen is that we can execute multiple tasks in a seemingly parallel way. So what I mean by that is that task one can be happening as well as task two can be happening at the same time, and task three. It's a pretty cool concept, isn't it? Now I think we have talked enough in terms of theory. Now let's go ahead and actually see it in action. So you remember I mentioned the term called threads. Now, threads is a way to achieve concurrency in Java. And each Java application, because it's powered by JVM, already has a default thread. We can spawn another threads so that we can take advantage of the concurrency, right? So let's go ahead and quickly define a thread so that you can see it in action. So this thread will be responsible for printing hello world. And let's we have to start every thread. Like to execute a thread, you need to call start on it. Let's run this. Now, as you would have expected, it printed hello world. Nothing to be surprised about, right? That's all cool. Now, one more cool thing we can do with threads is we can actually see that what thread it's actually being executed from. So to do that, we can use our string interpolation, and we can print thread dot current thread, and let's hit start again. Now, here you can see that it says hi from thread 05 main. Now, you might be thinking, what are these terms? It's just a way of defining what thread this is. So it is saying that it's the 0th thread, and this is the priority, and it's on the main thread. So you don't need to go into specifics of this, but it's just good to know that this is the thread number, the priority, and the thread it's being executed on, right? So from a single thread, we don't really get to see the power of threads. I mean, you got to see the syntax, and that's cool. But then now, let's actually try spawning multiple threads and seeing the power of them. So I'll clear up this thing, and I'll create a variable called states, and it will store some states of some strings. So let's say the first state is started, second is doing task one, and third is doing task two, and the last state is ended. All right. So state is just an array of these strings, and these represent different states of the thread, which we'll see now. So let's go ahead and spawn 3 threads. So to do that, you would have come across this keyword called repeat, and the repeat keyword basically executes whatever is inside the function block, the number of times we specify it to. So what we'll do here is we'll spawn a thread, and before we forget, we'll call start on it. And in each thread, we'll have a loop for I in states. We will print out the thread first of all, which thread it's actually being executed from. All right, and then we'll print out the state of the thread. Now, one more thing I like to do is print here too, which thread it's actually being executed from, so that we know when it started. As started. Now, um, before I execute this, go ahead and type in chat what do you think will be the output of this. Or even if you don't want to type the output, you can just go ahead and tell me, like, how do you think this will proceed? Just in simple terms, how do you think this program will proceed? I want to know it from you guys. So I'll be looking at the chats, and you can go ahead and answer this. I'll give you guys 2 minutes. So this is a little tricky question, but then if you can imagine how threads might work, you get the answer to this. So I'll wait for you guys. All right, I don't see any answers till now, and that's fine because it is something slightly a little confusing maybe. But then yeah, let's go ahead and execute it. So now you can see that, okay, so let's go through this output in detail. What is happening is, first it's saying that thread 1 has started, then thread 1 has the state of it is started, then thread 1 is doing task 1, then thread 1 is doing task 2, thread 1 ended, then thread 2, then here you can see that thread 0 started out of nowhere. So ideally, what you would have expected in a serial execution would have been that thread 0 would have first started, finished all of its states, then thread 1, and then thread 2. But in this case, it's happening in random order, right? So if you were to execute it again, I'm pretty sure the result will be different. Yeah, you can already see that the thread 2 has started initially. So this just proves that the threads are actually working in parallel, and there is no way to control which thread will occur first, or we have no way to find that out, right? Now, this was all about threads, and I hope this concept is clear. And if you have any doubts, you can drop them in the chats and I'll go through them. So, threads are amazing, but there are some limitations of threads. What are those limitations? The limitations are that they are quite computationally intensive. So, now what I mean by that is that they require a lot of resources, and that is because a, switching between threads is pretty tough for the CPU. And once you start making multiple threads, switching between all of them becomes a huge task for the CPU. And also there is a upper bound to how many threads you can actually have without affecting the performance. So imagine if you start like spawning thousands of threads, that is definitely gonna cause some performance degradation in your app and might start slowing down the performance. So not a really good thing to do. Now, how do we solve this? That is where Kotlin coroutines come into picture. So Kotlin coroutines are a you can think of them as a lightweight thread. They're not threads exactly, but they use they are an abstract over threads. So they use threads to perform functions, and they are very lightweight. So like to just like give you a context of how lightweight they are, you can literally spawn millions of coroutines, and you won't see any performance degradation. They'll work very smoothly, like they're very lightweight. Now, to give you a better and a clearer idea of uh, how our coroutines function, I mean, how our coroutines functioning, I'd like to show you this diagram. So here you can see that, suppose, assume that this is a thread, this is a particular a single thread, and what coroutines are is that they are individual tasks being split up and performed inside that thread. So whenever we say parallelism in computing, we don't mean true parallelism. So what that means is these tasks are not happening on totally different cores or different CPUs, right? They're happening on a single process or a thread, and they are being split up into multiple parts. They start, then they are suspended until they need to be brought into the CPU again, and then they perform the activity, and then they're suspended again. And while they're suspended, other tasks can come and perform complete their task and be suspended again. So coroutines have this ability to store its state. The function can store its state, be suspended, and then come back into the thread, perform, and then be suspended again. So here you can see, suppose coroutine 1, first it started its execution, then it had to wait, it went into suspension, and then like you could see coroutine 2 and coroutine 3 executed, then again coroutine 1 started execution, right? So this gives us a sense of parallelism. We won't get to differentiate that these things didn't happen in parallel, but these are actually happening serially. They happen so fast that we can't really differentiate between parallelism and serial execution of these, right? So I hope like you got the gist of coroutine. But again, to summarize, coroutine is something which is being executed on a thread, but multiple coroutines can be executed on a single thread, and they give us a sense of parallelism, right? Now, I think theoretically this must be clear. Now let's go ahead and actually see coroutines in action. Let's get rid of the previous code. To use coroutines, you'll have to import Kotlin X dot coroutines dot start, because we're just importing everything for the moment. Now, to use coroutine, what we'll do is global scope dot launch, and we'll go ahead and say print line hello from thread dot current thread. Now, don't be confused about the syntax. I know I didn't explain global scope and launch and what is this doing, but we'll get back to that. Now I'll just execute this so that you can see that this is a coroutine and this is working. Here you can see hello from thread default dispatcher worker 1, and this is coroutine number 1. And yeah, so what is happening here is that we are defining a coroutine scope. Now, what a coroutine scope is that it basically confines the executions of coroutines to a particular scope. Now, here the coroutine scope is a global scope. Now, what this global scope means is that until this application is running, the coroutines inside will be executed, right? That's their scope. And what this launch is doing, it's quite self-explanatory. It's launching a coroutine. So anything inside this block is a coroutine, and this function is being this print line is being executed from inside a coroutine. And now here you can see we printed the current thread, right? And in the output we could see that it's a coroutine because it showed default dispatcher worker 1 at coroutine number 1. So here this is on the thread called this default dispatcher worker 1 at coroutine number 1, right? So this was a coroutine. And now I hope this is clear. Now let's go on to a different example. And to explain that example, I'll just go ahead and copy the code because we don't want to waste some time on that. Also, yeah. So I'll just quickly go ahead and copy this from here. What this is doing is, as we saw in the previous example, to basically deploy 3 threads. Here we are starting 3 coroutines. So let's hit run on this. So here you can see that it is the first thread it's working on is default dispatcher worker 1, and it's the coroutine number 1. And the second is on dispatcher worker 2, and the third is also on dispatcher number 2. So here, like from this example, you can see that a single thread is taking care of 2 coroutines, right? Because these both are the same threads, and but they do contain different coroutines. So this is what I meant by a single thread can have multiple coroutines within them. Now let's move on to something slightly more detailed about coroutines. I'll again go ahead and copy the code from the code lab. And if you do want to execute it along with me, you can just copy this, right? So I'll go over the code. I'll explain everything line by line. So these are just the imports, and this is specific to formatting the time because we'll be using the current system time in this particular program. So you don't have to worry about this so much. Just understand that this is used for formatting the time. Now, this is the core of this particular program. This function called suspend fun get value, and it is going to be returning a double. Now, see, so first of all, you'll be confused about why are we using this keyword called suspend, because we haven't really come across this keyword yet. And let's just go through it. What this is doing is it is going to print entering get value, which is the function name, at time. Now this time is the current time, right? And then it is going to delay by 3000 milliseconds, which is equal to 3 seconds. And then it is going to call leaving get value at the system time again after 3 seconds, right? And then it's just going to return a random value. Now, why are we using this keyword called suspend? To use a function, to basically use a function within a coroutine. You can, okay, sorry, you can use a suspend function within a coroutine. And a suspend, to use suspend functions, you need to have a outer suspend function. So in this case, delay is a suspendable function. So we need to make this particular function suspendable. So now when we execute this function within a coroutine, the coroutine knows that this function can be suspended and it can be resumed. It can be brought back into that particular thread after this delay of 3000 seconds is completed, right? And that is what is represented by suspend. So now we'll go into the main function, and here we see that there's this keyword called run blocking. Now what run blocking is doing is that it is going to give us a sense of serial execution while still using coroutines. Now, why is that important in this particular case? Now, that is important because here get value is a suspend function and it has a delay of 3000 seconds, and it is only going to return a value after those 3000 milliseconds, right? And num2 is also going to do the same. And the last line here relies both on num1 and num2. So we want the values returned from get value for num1 and for num2. right? If we don't have the values of math.random in both of them, how will we be able to compute this, right? So we need both of these functions to complete first, and only then move on to the next one. So that is what is meant by run blocking. So by blocking, it means that it will occupy the entire thread until it's completed. You know how we mentioned before that in coroutines you can't take control of how much time the function gets on the thread, but in this case we will make sure that this get value function is completed, and only then we'll move on to the next line and then the next line. So let's run this. It will take 6 seconds to run because first it's a delay of 3000 milliseconds and then again a delay of 3000 milliseconds. So here the output we get is that it started at the fourth second. The first function started executing at the fourth second. Then it waited for 3 seconds. It left the get value at 7, so which is 3 seconds. Then the second num2 entered again at the 7th second and left at 10 second. Right. So it happened serially. The first one completed first with the 3000 millisecond delay. Then the second one completed, and then we moved on to print line and num1 plus num2. Right. So this was one case, and you might need to use run blocking multiple times because there are cases when num2 something like a function of num2 might be relying on the value of num1. So in those cases you'll have to wait for num1 to complete, and only then you can execute num2. So this was one approach. Now let's look at another very cool concept of async. Now, if you have seen other languages or you have tried programming in other languages like Dart or JavaScript or numerous other languages, they have the keyword called async and await. Now, what async? Okay, I'll just go ahead and demonstrate it to you first so that you'll get a better idea of it. We'll use a async block. To do that, all you have to do is just add async in front of the function call. And okay, so let's make this even more interesting. I will wait for you, and you have to basically tell me what do you think the output of this particular program will now be, right? Because we added this async block, and we are awaiting on the results right here. Now, I know you have never come across this before, but just take a wild guess. What do you think might happen now after adding the async blocks? I'll give you guys 2 minutes and I'll be checking the comments. So make sure to drop in a answer there. I'll give you guys like 1 more minute. Okay, so yeah, so Yajat has answered. It will wait for the values. Yes, it will wait for the values. That was happening in the previous case too. But now, actually, let's go ahead and execute this. I hit run, and now the interesting part is that the first num1 function of get value started at 47. The second one also started at 47, and they ended at 50 and 50. Now, what happened with this was that basically what async made happen was it allowed both of the get values to execute in parallel. right? So the first get value started execution, and as well as the second one. So both of them were executing parallelly, and it waited for them to complete, and it printed the result, right? And that's what this await function did. If we didn't have await, the program will crash, right? Because it won't know that it needs to wait for both of them. So this is a convenient way of having both of them run at the same time in a run blocking command, right? Because none of them depend on each other, and if we were doing it serially, we were taking 6 seconds to complete this particular thing, whereas if we are doing this parallelly, it's taking only 3 seconds to complete both of them, and we are getting the return result from both of them, right? So this is a pretty interesting concept of async and await inside run blocking keyword, right? So this wraps up coroutines, and this should be enough to get you through the Android part of implementing coroutines. And if you have any further doubts, you can drop them in the chat, and I'll be happy to answer them. So yeah, I think we're done with the coroutines part, and now again over to Jeevan for explaining HTTP and REST and building an app which will show you the images from Mars. Pretty interesting. Over to you, Jeevan.
Yeah, thank you, Ritik. It was a great section. I hope you guys understood a lot about coroutines and multitasking, concurrency, and everything. So, yeah, thank you, Ritik. So, we will be moving on to our next part of the section, HTTP and REST. So, before that, we will just have a small poll. I will give you the link in the YouTube chat. You can go to this link and post your response. So the question is, which is your favorite Kotlin feature? So we have seen a lot of features till now, like null safety, less boilerplate. Of course, we saw coroutines right now. So yeah, which one is your favorite Kotlin feature? We will see that. I will share my screen so that you can also see the responses. Okay, we have some responses here. We have sealed classes, coroutines, less boilerplate. We'll wait for like 3 minutes for you to type in your favorite Kotlin feature. Happy to see your responses here. So if you haven't responded yet, make sure that you go to this link that I have posted, or else you can go to this menti.com site and use this code 2605563. Okay, so we have some responses here, and I think most of you like less boilerplate, and just after that you loved coroutines. So nice to hear that. Okay, so we have more responses coming in. The most prominent ones are coroutines and less boilerplate. So yeah, thank you guys. Thank you for your response. We will have two more questions. Next up, we will have a quiz. So listen to the session and you can answer the quizzes coming up. Okay, so let's move on to our next part. Cool. So we have seen about coroutines till now. Now we are moving on to our next part, HTTP and REST. I hope my screen is visible. Cool. So what is HTTP? HTTP stands for Hypertext Transfer Protocol, and this is basically a protocol for communication. So if you see the figure here, we have a client and a server architecture. So this is what we call as a client-server architecture. The client, you can think of your app running on your user's mobile, and the server, you can think of a computer or a group of computers hosted somewhere on the cloud. And what the client does is client will send a request to the server and the server will give us back a response. So this is a very basic understanding of how this client server thing works. And how is this communication done? There should be a protocol, right? There should be a set of defined rules for how the communication should be done. And this is called as a protocol. And the protocol that we use here is called HTTP, or the Hypertext Transfer Protocol. And this is a client server architecture. So what is a HTTP request? So I will give you an example. So this is a GET request. So GET is one among the HTTP request methods. We will see other methods in a few slides. And it is going to access the search endpoint, followed by a parameter called query, which has the value Android. And the host is google.com. So this is basically happening when you do a Google search on google.com, you enter a keyword, and when you press enter, you are doing a HTTP request to Google server that you are giving a GET request with the search query Android. So yeah, this is what HTTP request looks like. We will just look at the components of a URL so that you will get a better idea of how this works. So this is how this is an example for a URL. This is the URL when you do a Google search with the keyword or the search query as Android. So let's just split this up or break this down to different components of a URL. The first up, we have HTTPS, which is the protocol. It stands for Hypertext Transfer Protocol Secure. Followed by, we have www.google.com. So this is the host. This is the address of the host that we are trying to communicate. Followed by /search, which is the endpoint or the resource that we are looking to access. So this search is an endpoint that we are accessing here. And if you have any parameters to a request, you are going to append it using a question mark. Here we have a search query with the value Android. And this is a URL parameter. This is what we call as a parameter. If you have multiple parameters, it will be separated by an ampersand symbol. For example, another example for a URL is when you watch a YouTube video, you will be having a URL like https www.youtube.com/watch v is equal to that particular ID of that video. And if you have a timestamp, it will contain ampersand t is equal to 10, which means the playback should start from the time 10. And the parameter for the video ID is going to be that particular thing that you have inside the URL. This is another example for a URL. It has similar structure. So first thing you have is a protocol, then you have the host, then you have the endpoint, then you have URL parameters. Now let's take a look at different HTTP request methods. So these are the most commonly used HTTP request methods. First one is GET, then we have POST, then PUT, and finally DELETE. We will see this with an example of a social media app. Let's say you're going to post something on Instagram or Facebook or whatever else that you like. When you take the home screen of the social media app, what you will see is a list of recent posts made by those who you're following, right? So at that time, you're making a GET request. So you want to get all the recent posts. So you're making a GET request to the server, and then you are getting all the posts from different people. Let's say you want to post something, you want to upload a photo. At that time, what you're going to do is you're going to give a post request. That is, you're going to send some data to the server. That is, you're going to send the image file and you want to post it to your feed. So that is, you are doing a post request there. Let's say after posting the new photo, you find that you made some mistakes in the caption. So what should you do? Should you delete the entire post and repost it again? No, you can edit the caption, right? So what you're going to do there is a put request where you can update, you can send an update request to the server. Finally, when if you find that your post is not working out, you can always delete your post. You can take back your post. For that, you're going to do what you're going to do is a delete request. So these are different request methods for HTTP request. So these are the majorly used methods: get, post, put, and delete. And then, as we said, the client sends a request to the server and the server gives back a response. So these are the response codes, commonly used response codes. So these response code shows us what is the current status of the response. So if the code is within the range 200 to 299, it is a success, which means our request was good and we got a successful response. If it is within the range 400 to 499, it means it is a client side error, which means there was some error from the client side. It made a bad request or something. Then finally, if you have a response code within the range 500 to 599, you have a client side server side error, which means some error occurred from your server end, some internal server error occurred. Then you will get a response code within 500 to 599 response code. So we saw about a brief introduction about HTTP request methods. Then we saw response codes and basic client server architecture. Next thing that we have is REST. So when you're dealing with a real life application, when you're going to develop an app, most of the time we will be handling REST APIs to communicate with your backend server. So what is a REST architecture? So REST basically has some criteria. So this is not the complete list of criteria that the REST requires, but I'm just explaining only these 4 points, main points here. The first thing is client server architecture, as we saw in that particular diagram. It should have a separate distinction between the client and the server. It should have a uniform interface. It doesn't matter from which device are you communicating. You may be communicating from a browser or your mobile app. So whichever platform are you communicating from, it should have a uniform interface. Like it should have an API with a particular endpoint, and it should be uniform to all devices that is communicating to the server. Then resources exposed as URIs. What does this mean? For example, in the Mars Photos app that we are going to build today, we will be getting URLs of images. So these images is hosted on some server, right? But we are getting that resource as a URI. So you can access that resource. So it should be exposed as URIs. And finally, it should be stateless, which means the server doesn't need to know what was the previous state of the client that is sending you a request right now. For example, if I am sending a put request to the server, the server shouldn't bother about whether the client has already posted something or something like that. It doesn't need to know about the state of the client. The request should always have the enough content to infer what is the need of the client right now. So it doesn't need to know about the previous state or the next state. It should be stateless. So these are some basic criteria for REST APIs. So yeah, this is what we mean when we say we are going to use some REST API. So before we move on to the Mars Photos app that we have, I would like to explain two keywords here: view model and live data. So before we move on, let me know in the chats if you are having any doubts regarding HTTP or REST. You're right, Yajit. Twitter doesn't have a put request. Yeah. So I hope everything is clear. If you are having any doubts at any point of time, you can always post it in the chat section. we will be helping you out. Okay, now let's move on to view model. So what is a view model? A view model is a special type of class which is going to hold your data for your app. So till now we have been using the main activity.kotlin file or the fragment.kotlin file to handle the logic to display the data inside your XML file, right? So we have been writing some logic within our activity file or fragment file, and we have been directly putting the data to the layout from our activity file. So there are some issues with this. I will say an example. Let's say you have a text view with a value as 10 set from the Kotlin file. Let's say you change the orientation of the device. You change it from portrait to landscape. When you do that, you might notice that that data of 10 is lost and it is set to 0 or a null value. So why did this happen? The data is lost when the life cycle of the activity changed. So when you change the orientation, the activity just restarts. So the data just got lost. To avoid such situations, we are going to use something called a view model, where you are going to separate your logic and views into two different classes. So we have two things here. You have a UI controller, which is basically the activity or fragment, which handles all things about views only, which means all your click listeners, all initialization of text views and everything will happen inside your UI controller, and no logic will be written there. No logic regarding the data, or the data is not going to be directly set to the text or something inside your UI controller. All logic regarding the data will be inside what we call as view model. So view model is basically a special type of class which can hold your data that is needed for the UI, and it prepares for the display. So the main concept here is the view model shouldn't have any instance or any reference to your activity or fragment. So it should have a clear separation. And we are going to use this view model inside the Mars Photos app that we are going to build. Then we have live data. So what is live data? Live data is, in simple words, an observable data holder class, which means you can always observe for changes in this particular thing called live data. So what we are going to do is we are going to have a live data variable with our whatever type model of data that we want. And there is always something called an observer, where you can observe for changes inside this live data and act accordingly. Like if there is a change, what should be done, that you can write in your logic. So that is why we are going to use live data, because it is life cycle aware, which means also one thing about view model is the view model will hold the data throughout the life cycle changes. So it doesn't matter whether you rotated the screen or change the orientation or anything, it will always hold the data within view model. That's how we are solving the data loss issue. And about the live data is also life cycle aware, and it is going to help us in observing the data for any changes and do the stuff accordingly. So we are going to use both this view model and live data in our app that is coming up. So yeah, without spending much time, we will move to the Mars Photos app. So we are not going to build this from scratch. We are going to we have a starter code provided in the course content itself. I will post, this is the app which is going to look like after we complete today's session. So this should be the final look of the app. You have a recycler view here with images loaded from internet. We will use retrofit to call the API to get all this data. Then we will use Coil library to display images inside an image view from these URLs that you're getting. Also, we will use view model and live data inside this app. So before we get started, let's download the starter code. I will post the link inside YouTube chat as well. And before we actually start building the app, we will take a small break of 3 to 4 minutes. So you can stretch out, sip some water, and come back with more energy. We're going to build something amazing. So I will paste this link in the chat. Okay, so I have posted the link to the starter code in the YouTube chat. You can go to this link, and from this code part, you can download the zip file. And I'm going to save this inside downloads folder. Till then, we will take a small break and get back. You can use this time to download this as well from GitHub, the starter code, and you can code along. We'll have a small break of 3 to 4 minutes. We will start exactly at 8. Now it's 7:57. Also, we will be available in the chats even during the break time. If you are facing any issues or errors, you can always post it. We'll be really happy to help you out. Okay, so I hope you have downloaded the starter code. I'll share my screen once again. Okay, so you can unzip this. Okay, so what we are going to do is we are going to start Android Studio and import this project. So let's get to Android Studio. And we are going to import the project here. So for that, go to this more actions option that you have on the right, top right corner. And here you have an option to import a project. Click on import project. And inside that, we are going to open this Android Basics Kotlin Mars Photos App Starter. Let's click on this project and click OK. It will just import the project for us. If you're doing this for the first time, it might take a little time. It will do the Gradle build and sync our project. Okay, so till then, let's see what is retrofit and how it is going to help us. Okay, so as we said, we will be using retrofit to call APIs. So what is the role of retrofit here? Retrofit is a library for Android, and we are going to use this for communicating with an API. So we will have an API to get these photos from get these Mars photos, and we are going to have some parameters for this API, right? So we are going to provide these parameters to retrofit, and retrofit will convert this to a HTTP request that we saw earlier, and it will send it to the server. So the server will send back a JSON response, and finally we will get the output as Kotlin objects. So we have seen model class and everything in the last session, right? So for example, in the affirmations app, we had an affirmation model. So similarly, we will have a data model for this app as well. So we will get our result in the form of that particular data class object. So this is the role of retrofit, and we are going to use retrofit to communicate with the API. Okay, so before we I will give you a little time so that your project syncs with the Gradle and everything is ready. Okay, so before building our Mars Photos app, let's have a small quiz so that we are. It is regarding the HTTP part that we covered just now. So you can go to the link that I have already posted in the YouTube chat section. Okay, so start joining in, guys. We will have a small question. Okay, you can use the same link as before. Okay, so I'm waiting for you guys to join in. We have someone here. I'll wait for like 2 minutes. Okay, so we have some players. Let's get to the question round. Cool. So which of the following is not a HTTP request method? That is a question. Answer fast. Okay, so the right answer was push because it is not a HTTP request method. Let's see the leaderboard. Okay, so we have the winner here. Congratulations. So, yep, let's move on. Let's get back to our Android Studio. Okay, so the project has been imported successfully. Let's take a look at what all things are already available here. Inside your main package, you have an overview package here, inside which you have an overview fragment and an overview view model. So inside this overview view model, this is what we were talking about view model a few slides before. This is going to hold the data for our overview fragment. So the overview fragment is basically this fragment which is going to hold this images, and this overview view model is going to hold the data for our fragment. So let's get back to Android Studio and see what all things are available. Then inside the layout file, we have the fragment overview.xml file where you have a text view for now. So for the first step, we will be pasting the row response inside the text view. I mean, we will be setting the text for the text view as a row response. And later we will convert this to a recycler view with images. Then we have a grid view item. If you remember from the last second session, when we were talking about recycler views, we had a list item.xml, right? So this is going to be the design for the single grid item that we are going to have. In this example, it is just an image view. And yeah, these are the things that are already available here. So what we are going to do first is we have to add the dependencies for retrofit and coil as well. So first up is retrofit. So we are going to set up the network layer first so that we can call the API and get the data. For that, I'm going to this Android basics in Kotlin codes. We're just going to copy the dependencies from there. Inside the internet unit, you can get the dependencies. Okay, so if you come to this get data from internet part inside web services and retrofit, you will have lines saying the implementation. I'm just going to copy this. I will paste this in the YouTube chat as well. Okay, so we are just going to copy this to our project. So for that, open your build.gradle file, the module level build.gradle file, and scroll down. Below these, inside the dependency tag, we are going to paste what we just copied. And also, make sure that inside your project level build.gradle, inside your repositories tag, you have Google and Maven Central. This should already be there, but just making this sure. You have Google and Maven Central. Then inside your module level build.gradle, we just added 2 dependencies for retrofit, and one is for retrofit converter. We will talk about converters in a few moments. And now we are going to sync this with Gradle. Okay, so it is done. And right now we are going to set up our network layer for this particular application. So as we have seen in our previous day's session, we created a new package for model adapters and everything, right? So here we are going to create a new package for our network layer to organize our code and make it more readable in future. And what we are going to do is inside our main package, we're going to have a new package. By right clicking the main package, we are going to have a new package, and I'm going to give its name as network. And inside this network package, what we are going to do is we are going to create a new Kotlin file inside our network package, and I'm going to name it as Mars API service. Press enter. So we just created a new Kotlin file with Mars API service as the name. We are going to have a private constant value called base URL, and it is going to have our base URL for our API. So this is how it is going to work in our real life application. Also, you will have a URL of your API where it is hosted. So your backend developer will give you the URL that you should call to get to access your API endpoints. So for this purpose, what we are going to have is HTTPS Android-Kotlin. I will paste this in chat as well. On Mars server.appspot.com. Just making this to make this sure, we will just see this. This is available inside your codes file. So yeah, this is our base URL. We'll paste this in the chat also. Okay, so you can find this in the chat. And next thing, what we are going to do is we're going to create a variable for retrofit. So we are going to make an object of retrofit, and we are going to initialize it as retrofit.builder. And we are going to add some things here. We're going to add something called a converter factory. So what is a converter factory? We will see in a minute. And we are going to pass the value as scalars converter factory dot, and we are going to call the create function for that. And then we are going to add the base URL. So for that, you have a function called base URL here. We are going to pass the value as this. So the base URL is going to be this. And then we are going to build this. So we created a retrofit object by calling the retrofit.builder method and added a converter. So what is a converter? As we saw in here, retrofit is going to convert the response from server to what we need, right? So for this scalar converter, what we are going to do is we are going to convert the response to a string type. and we are going to get that. Later we will change this converter, and we will add something called Moshi, and we will see that in some time. So right now we just created a retrofit object by calling its builder method, and now we are going to define an interface, the name Mars API service. So this is the name of this particular file. What we are going to have here is a function called get photos. So this function is going to be called whenever you want to get photos inside your view model. So we just defined a function called get photos, and it is going to return something of type string. And right now we are going to use an annotation called get. And if you notice, this notation comes from the retrofit library that we just added to the dependencies. So this is where retrofit comes into play, and we are going to pass some value called photos here. So why are we doing this? We will see. So this get annotation comes from retrofit library that we added in dependency. So what we are doing here is, when you are going to call this get photos function, it will convert our request to a HTTP request, which will be of type get, because this request is going to be a get request, and it is going to call the endpoint photos. So in the Google example that we saw, it was google.com/search, right? So this photos is similar to that search. So what we are doing here exactly is, we are going to call this URL followed by /photos. We will just try to copy this to the browser, and let's see what is the response, followed by photos. Okay, so we have a very big response here, if you see. So this is what we are going to get inside our app. So we should get this response inside our app. And for now, we are going to set this as the text of the text view available there. This is basically a JSON format. We will see the format in detail. And it has something called an ID and image source, which is a URL, which is repeated continuously. And we have different image URLs in each object that we have. So we will see that and display these images in a recycler view finally. So this is the data that we should get. And for getting these endpoint /photos, that's why we are using this annotation here. This is going to be a get method, and followed by this endpoint photos. And we have defined the return type as string, because we are going to get the row response here. Now we are going to create an object. So we have seen companion object in our previous session, right? So we are going to define something called an object with name March API. So why are we doing this? Because if you are going to call this March API service each time that you want to get photos, it is going to be really expensive. So we are going to have a singleton instance, which means you will have a single instance of this March API throughout your program. So you can access the same instance again and again without creating new instances again. So we are going to have a singleton instance here. So that's why we are using the keyword object here, followed by a name March API. And what we are going to do inside this is, we are going to define something called retrofit service of type March API service. So it is type of this interface. Then I'm going to use the lazy keyword here. We are going to create retrofit.create. We are going to call the create method of retrofit object that we created here. And we are going to pass this March API service interface for that. We're going to pass this class March API service. We are passing this interface inside our retrofit.create method. So we just created a singleton object of March API here. I will give you 2 minutes to catch up. What we did till now is, we were setting up the network layer. We created a new package called network inside our main package, March photos package. Then we created a new Kotlin file called March API service. We defined a constant value called base URL, which has the value for your API's address. Then we created a retrofit object using retrofit.builder method. We added a converter called scalar converter factory. Then we added the base URL to the retrofit object, and finally we built the retrofit object. Then we defined an interface called Mars API service, where we wrote a function called get photos, and we added an annotation from retrofit which specifies that this is going to be a get request, and we are going to access the endpoint photos. And finally, we created a singleton object called Mars API, which will create the retrofit service for us when you create an instance for this Mars API object. And we are going to do one more thing inside the interface. So we have seen coroutines in the first section of today's session, right? So for a function to be able to be called from a coroutine, it should be a suspendable function, right? So we are going to add the keyword suspend before function so that it can be called from a coroutine scope. So we are going to call this from something called a view model scope. From our view model, we are going to use coroutines to call this API in our background. So if we are going to call our API on our main thread, sometimes it may take too long to load this response, right? So it may cause the UI to get stuck. So we are not going to do that. We are going to have this simultaneously. So that is what we mean by concurrent. So for that, we are going to use coroutines. So that's why we saw how coroutines work. And for this function to be available inside a coroutine, we are going to use this keyword suspend. So we just defined our network layer here. So I hope it's clear till now. We will just move to the view model class. So inside our overview package, we have an overview view model here. And what we are going to do here is we are going to make some changes inside the get Mars photos function that we have here. So it is a private function here. What we are going to do here is we are going to launch a coroutine and we are going to call our API. So for that, what we are going to do is inside our get Mars photos function, we're going to use view model scope. So it is a coroutine scope, view model scope dot launch. And inside this curly braces, what we are going to do is we are going to call that get photos function. For that, I'm defining a value called list result, which is going to hold the result that we get from API. And we are going to call it Mars API. So remember that this Mars API is that singleton object, this thing that we wrote here. And we are going to call the retrofit service. This retrofit service is this thing that we have. And then we are going to call the get photos function from that. So this is going to return a string. The return type is string here. So we will be getting a string inside the result here. And we are going to set the value of this underscore status variable as this list result. So this status value is what is going to get updated inside this text view. So this text view will show us the row response that we are going to get from the API. So since we are going to use internet to call this API from your app, you should do this thing inside your manifest.xml. So let's go to this manifest folder, and inside that you have Android manifest.xml. We're going to open this and add a line inside our manifest tag, but outside the application tag. We are going to give a tag called users permission, and the name is going to be android.permission.internet. And we are going to close this. So what we are doing here is we are adding the permission for this because we need the permission to access internet so that we can call APIs over the internet. So we added a permission here. Also, it is always a good practice to do exception handling in case you have any error in between calling the API. The app shouldn't crash, right? So for that, let's get back to our view model, and inside this view model scope, what we are going to do is we are going to surround this by a try catch block. We're going to write try, Within this, we are going to put these two lines. And if there is an error, we are going to catch that. If there is an exception, what we are going to do is we are going to set the value of the text view as, we will say it was a failure. We are going to use string interpolation here, $sign followed by curly braces, and we are going to set the message of the exception as the text there. So we just surrounded our API calling part inside a try catch block, and we added a permission for this internet as well. Let's now try running this. I'm running this on an emulator for now. Let's see if we are getting data from internet. Okay, so it has launched the app. Let's see what is the response. Okay, so we got the response from the API. So if you notice, this is the response that we got in our browser screen, right? So this is the raw response that we are getting. So we are successful till now. We successfully fetched some data from internet using the retrofit library. So yeah, we are successful till now. We got the data. So this is the raw data that we are getting, but this is not what we want. Actually, we want to show this images as actual images inside image view, inside a grid, right? So we are going to do that. I hope it is clear till now. If you are facing any issues, let us know in the chats. I hope it is clear. Cool. So as I said, we were using something called a scalar converter till now. But right now, what we are going to use is a converter called Moshi. So why are we going to use Moshi? Because we need to get the response from retrofit as Kotlin object. So we are going to write a model data class for this app. So if you remember, from inside our affirmations app, we had a text and an image as the model for that particular affirmation app, right? So we had an affirmation data model class. So inside this, we are going to have a model class called Mars Photo, which will have two parameters. One is going to be ID, and the other one is going to be image source. So this is our response, right? So this is the thing that is repeated again and again. So this single thing is a data model for us. This is going to be the model is going to contain an ID and an image source. So this is going to be our data model, and we are going to add that data model to our project. So before that, we are going to add this Moshi converter. For that, let's copy this dependency. We need this implementation. So I'm just copying this from our course content and pasting this inside our module level build.gradle. I added the Moshi Kotlin implementation. Then we are going to replace this converter with Moshi converter. It's going to remove the last two lines and paste this. Now let's sync with project. Okay, so we have added the Moshi converter here. So why did we do this? As we saw in here, this is something that we call as a JSON response. So what is a JSON essentially? So JSON means the thing that you see here is a JSON array. So the thing that is inside the square brackets is a JSON array, and it is going to contain what we call as JSON object. So the things that inside this curly braces is called a JSON object. So JSON object is nothing but key value pairs. You have a key of ID here, and value is this particular thing. You have a key called image underscore src, which has some value here. So this is a JSON object. So a JSON object can have keys with value as another JSON object or even another JSON array. So that is also possible. So this is how a typical JSON response looks like. This is a JSON array, and you have different JSON objects within an array. And in this particular response, we have a simple array of JSON objects, and inside each JSON object, we have two keys, ID and image source. So yeah, this is going to be the JSON response that we are going to get. Cool. So we added the Moshi converter here. Let's create the model class for this project. So if you remember in our last affirmation SAP example, we created a new package for models, and we placed our data model in there. So it is actually the best practice to do in a real life application or the real world application that you're going to build. You will have multiple models, and you are going to place all these models inside the model package. So you can do that. So in this particular app, we are just going to have only single model. So for that, so I'm going to place it inside the network package that we have. So I'm going to create a new Kotlin class here, and I'm going to name it as Mars Photo. And it is going to be a data class. So we are going to add the keyword data. And we have two things as we saw. One is an ID of type string, and another one is an image source URL of type string. So if you see, this ID refers to this particular thing that we have here, this ID, this key. But next thing what we have is image src URL, which is written like this. But inside our actual response, it is img underscore src. So this is the naming convention for Kotlin. We have camel case here. But inside your backend framework might have a different naming convention. So it will return something like this. So how are we going to connect the actual key with the variable name that you gave here? For that, we are going to use something called a JSON annotation. For that, we're going to write @JSON. And we are going to give the name as this thing that we have here, which is img underscore src. So this thing maps with our actual response. So this variable img src URL is going to get mapped with the actual img underscore src thing inside our response. So this is why we are using Moshi. So this is going to do all the mappings for us. So yeah, we created a data class with an ID. So this ID is same as that we have in the actual response. So we are not adding a JSON annotation here. But here, the image source URL is a different name that we gave here. That's why we're mapping this with the actual response, actual key from our response. So we just created a Mars photo here, Mars photo data class. And let's get to our Mars API service. We might get an error here because we removed the scalars dependency, right? So let's remove this import. And instead of scalars scalar converter, we are going to use Moshi converter. So for that, we are going to have a variable called a private value for Moshi. And it is going to be moshi.builder. It's very similar to creating a retrofit object. So, and we are going to add something called Kotlin JSON adapter factory. And this is a built-in thing that comes within moshi.kotlin dependency that we added. So we need this to convert our JSON response to the Kotlin object that we define. And then we are going to build this. Okay, so we created a Moshi object here. And instead of scalar converter factory, what we are going to do is we are going to create a Moshi converter factory, and we are going to pass this Moshi object inside this. So we just changed our converter from scalar converter to Moshi converter factory so that we can get our response as Kotlin objects. So yeah, and as we discussed, what we need is not the raw response, right? We need a recycler view, so which expects a list of data. So our response is actually going to be a list of what? List of March photo. So if you remember, inside our affirmations app example, we had a list of affirmations, which was the type of response that we returned from our data source, which was local at that time. We just created a class called data source and returned a list of affirmations there. So right now we are going to get this data from internet from our API, and we are expecting a list of Mars photo, a list of this. So what is Mars photo? Basically, Mars photo is nothing but this data model with an ID and an image source. So we are expecting a list of this thing. So we changed the return type of this get photos function as list Mars photos. Let's get to overview view model. We will have an error here because this is no longer a string. So we cannot set this directly to our text view. So what we are going to set here is we are just going to say that it is a success and we got list result is now a list, right? So we are going to use string interpolation list result dot size. So we are going to just write it was the response is success and the list we are appending the list result dot size so that we know how many photos that we got, right? So we are setting the value of the text view as we got this many photos, and inside this exception it remains the same. If it is a failure, we are going to show this message here. Let's now try running this. We should see the number of photos that we are getting instead of the raw response here. Okay, so it is running. Okay, so we got the response as success, 838 photos. So yeah, our logic is working till now. We are getting a list of March photos and we just set the size of that list as our response here. Up next is we are going to change this, going to remove this text view, and we are going to place a recycler view, which is basically going to be a grid, and it will show the images. We will do that. So I will give you guys 2 minutes to catch up, and if you're facing any issues, let us know in the chats. Okay, so before we actually move on to building our recycler view, let's have a final quest for the day. Go to the same link. I'll post the link once again inside YouTube chat also. Okay, so I hope you have joined the link. Okay, let me just reload this. Okay, so we have people joining in. I'll wait for 1 minute for people to join. Cool. So, yep, let's go for the question. So, which of the following is not an image loading library in Android? So, yeah, give your answers fast so that you get more points. Okay, we have 30 more seconds. If you haven't marked your answer yet. Okay, 3, 2, 1. I'm up. Okay, so the right answer was butter knife. Let's see the leaderboard. Okay, so we have Dragonite winning here. So congratulations. This was the last question for the day. Cool. Now let's get back to our Android Studio. Yep. So what we did till now, we just added the network layer, we added the data model, we added Moshi converter inside our map Mars API service. We just made some changes. We changed this to a Moshi converter and we changed the return type of list of Mars photo. Inside the overview view model, we just changed the uh, value for text, right? Cool. So right now, what we are going to do is we are going to add the dependency for coil. I will paste it. Okay, so I have pasted the link for coil in the chat. Let us copy this. This is from the course itself. So we are going to copy the dependency for coil here. Let's get to build.gradle module level. Then we are going to add this coil dependency and sync it with the project. Cool. So we added the dependency for coil. Also make sure that we have already seen that we have Maven Central in here, so no need to worry about that. Now we are going to make some changes in our view model. Let's get to our view model here, and we are going to make some changes in here. So we have something called underscore status here, which is of type mutable live data. So as we discussed, live data is a kind of data that is observable, that you can observe for changes inside live data. So we are going to have another private mutable live data. So what is a mutable live data? Which means you can change the value of that live data. So we are making the access private. We are going to allow changes only within this view model, and we are going to expose this thing as a read-only thing without an underscore. So we are going to do the same with the list of photos as well. So yeah, we're going to have something called underscore photos, and it is going to be of type mutable live data. For now, we are going to keep the type as March photo. So as an initial step, we will just try to show only the first image from our response inside an image view to see if everything is working. Then later we will change this to the list of photos. So this is going to be a mutable live data. And then we have a public variable called photos. It is going to be of type live data, not mutable, of type March photo. And it is going to be get the value from the private variable that we have. Cool. So we just added a live data for the March photo. And let's come to our get March photos function. And inside our try block, what we have is we have a value called list result here, right? Instead of this, we are going to set the value of this mutable live data, this photos mutable live data, as the response that we get from retrofit. So what we are going to do is we are going to set underscore photos dot value is going to be this March API dot retrofit service dot get photos. So this get photos is returning a list, right? So what we are expecting is a single March photo. As I said, as an initial step, we are just going to show only the first image to see if it is working. So for that, we are going to get the first element of the array by using square bracket and the index as 0. And then inside the text view, what we are going to show is the URL for the first image. So let's say first image URL as photos dot value is going to be our March photo, and then we are going to access the URL. So we are going to set the URL of the first image as the text of text view. Cool. So yeah, let's now try running this. We haven't done anything about the image view yet, but we have to see the URL for first image here to see if it is working. Let's try running this. Okay, so we have the URL for first image here, and yeah, our code is working, our live data is working. So it is updating the value for live data, and we are accessing only the first element here. That's okay. We are going to use the list pretty soon. Okay, so we have something interesting here. So if you go to the build.gradle file and scroll up, you might notice inside our build features, earlier we were using view binding, right? But inside this project, it is already, since we downloaded the starter code, it is already written data binding true. So what is this data binding? We have seen what is view binding. You can access your XML elements within your Kotlin file. So what is data binding? Data binding is a two-way thing. View binding was a single way. You can access your XML elements inside Kotlin, but you cannot do the other way around. So data binding is both ways. You can access your data from your XML, and you can access your XML elements from your Kotlin file. So it works both ways. So we are going to use data binding inside this, and we are going to use something called binding adapters. So how the binding adapter is going to work, we will see in a minute. So let's create the binding adapter first, and then we will see how it is working. So inside our main package, I'm going to create a new class, new Kotlin class called binding adapters. And we are going to write a function called bind image. It is going to accept. We will see how this is working. This is going to work in a few moments. So yeah, this is going to accept an image view of type image view, and it is going to accept image URL of type string, which can be null. So we wrote a function for bind image here, and we are going to use a decorator, uh, an annotation called binding adapter, and it is going to have a value called image URL. So why are we using this? It will become more clear when we go to our XML part. And inside this bind image function, what we are going to do is we are going to load this URL. So for that, we are just checking for null, and we are going to use the let statement. So let basically means it gives you the context of this image URL throughout this curly braces. And we are going to load the image using our Coil library to the image view. So how are we going to do that? Inside that, we are going to have value called image URI. Notice that this is not URL. We are giving a name as URI. You can give whatever name you like. And what we are going to do is we are going to convert this URL, the string, to a URI, then call the build upon function, followed by we are going to give the scheme. The scheme is HTTPS. Then finally, we are going to build the URI. And now we are going to load this URI to the image view. So image view dot load. So if you notice, this load function comes from the Coil library. So that's where the Coil comes into play. We are going to load this URI to this image view using Coil library, and we are going to pass this image URI inside this load. So yeah, so this is why we are using Coil library. We need to load the URI to the image view. So that's why we are using Coil library. So we wrote a function called bind image. So where is this going to be used? So we will see that. For that, let's go to this grid view item.xml file, and inside this, if you notice, we have a layout tag here. So in our previous examples, what we had was on if you go to fragment overview, you have a layout as the base element here. Inside that, you have constraint layout. So in our previous example, we had a base layout as constraint layout and other views inside that. But since we are using data binding, this is going to be the structure for your XML file. You are going to have a tag called layout, and we are going to have something called a data tag inside this, so that we can access data variables inside our XML itself. So for that, we are going to have a data tag. Inside that, we have a tag called variable. I'm going to give the name as Viewmodel, and the type is we are going to give this as the Viewmodel that we already have inside our overview package. For that, I'm going to give the entire path as form dot example dot android dot march photos dot overview view model. So we are giving this value, this overview view model, for this particular variable called view model. So now we can access everything inside this view model inside our XML. So for that, what we are going to do is we are going to add a line to this image view called image URL. We are going to use app prefix here, app image URL, and it is going to be, notice this syntax, @ curly braces, and within this curly braces, what we are going to do is view model dot photos dot image source URL. So what is this? This view model dot photos is a live data, and it is of type Mars photo, right? So inside this Mars photo, we will have an image URL. So if you notice, inside our data class, we have an image URL value, right? So we are getting that inside our XML, directly inside our XML file. So for that, that's why we need a binding adapter. So now we will see why did we add annotation and everything inside of a binding adapter. So if you go to the binding adapter, this bind image function has a binding adapter annotation with this image URL value, right? So this image URL should be same as this thing that you have here. So when this is written, it will always call this bind image function by passing this image view and the value that you have in here. So this is going to be the actual image source URL when you load it from the API. That's why we are using a live data, because since this is a live data, it will automatically observe for changes. And when you have a data inside this, it will automatically call the bind function and use the coil library to actually show the image. So this is the internal working that is happening. That's why we are using live data view model along with data binding, so that we can directly give the data inside your XML file. Right now, what we did is we just changed the grid view item. We are just showing a single, as we said, we are just showing a single image right now to see if everything is working. So for that, we have to make a little change in our fragment file also. Right now, we have fragment overview binding here, which is this fragment overview.xml file. Let's comment this out for now. And we are going to give the value of binding as grid view item binding dot inflate. I'm going to pass the inflator here because we need to show only this grid view item dot xml for now. This is just temporary. We are going to make this back to the older form. But for now, to see if it is working, we are just going to run this and see if the image is loading. Sometimes you need to rebuild the clean and rebuild the project to get this grid view item binding inflator. Let's try running this and let's see if it is working. Yeah, so we got an image. We were showing only the first image from the response, right? So the first image from the response is this, and we got the data using retrofit and we loaded it to an image view using coil. Yeah, so we are successful till now. What we are going to do next is we are going to have a recycler view, which is going to be a grid. And the experience that you got from building a recycler view from previous session is going to help you here. So we are going to use the recycler view adapter and everything from our previous examples. Cool. So I hope it is clear till now. We will make this as earlier. We are going to remove this grid view item binding and we are changing this to back to fragment overview binding because we need to show this fragment overview only to the user. So we have this binding as the previous thing. Inside our overview view model, if you see, right now we have Mars photo as the data type inside mutable live data, right? This is because we needed to show only the first photo from the list, but our actual need is a list of Mars photos. So we are going to change the type to list. And we are going to change the type here as well to a list of Mars photo. And we are going to change the status dot value as just success. And now we don't need to access the first element. We can directly set the value that we get from retrofit because this is already a list of Mars photo. And now the photos is also a mutable live data of type list of Mars photos. So we can directly assign the value that we get from get photos function. So we change the type from Mars photo to list of Mars photo. What we are going to do right now is we are going to do some changes in our grid view item. We are going to remove this view model variable here. We are going to change this to another variable called photo. I'm going to give the name as photo, and this is going to be of type of that data model that we have. So I'm going to give the entire path pom.example.android.marsphoto.network.marsphoto. So this is our data model class, and I have given the entire path to this. And here, what we are going to do is, instead of viewmodel.image source URL, we are going to use photo.image source URL. So this photo is this thing that we have here. And this is inside grid view item.xml. And now we are going to our fragment overview.xml file, and we are going to remove this text view. We don't need this anymore. What we need is a recycler view. So just type down recycler view and press enter. We need this to fill the entire width and height. So what we are going to give is 0 dp and 0 dp. If you remember, this is what we do inside a constraint layout. So for match parent, we use 0 dp, and we are going to set the constraints. So this should be very familiar to you at this point of time. So we are going to give start to start of parent, end to end of parent, then top to top of parent, and bottom to bottom of parent. So now it fills the entire screen. Let's give this an ID. Let's say photos grid. Then we are going to give the layout manager. If you remember, in our previous example, we used something called a linear layout manager. At that time, we needed to show everything one below the other. So this is going to be a grid. So we are going to use something called a grid layout manager. So you can select this grid layout manager here. And we are going to use define something called a span. So what is a span? Span count, we are going to give it as 2. So what does this mean? We need to have 2 elements in a row, right? So that's why we are giving span count as 2. If you remember from this, we have 2 images in a row. That's why we need a span count of 2. And if we need to see the preview of how this will look like, we will add something called tools list item, and it is going to be the grid view list item file that we have. Just click on this and it will just fills in the data for us. So this is just for the preview. This will not be shown in our actual app when we run it on an emulator or the actual device. This is just for preview. If you remember, we used something called tools text for a text view to see how the text view looks like inside the preview, right? This is the exact same thing. We are just having this list item for just for preview. You can also have something called tools item count as a number you like, so that many number of items are shown. Cool. So yeah, we have added a recycler view here. Let's give this a small padding of 6 dp so that it doesn't look very cluttered. Cool. We added a recycler view. We added the constraints. We gave an ID, then defined a layout manager, gave the span count as 2, and just for some review purposes, we added this list item count and padding. Okay, I'm just formatting this using Control Alt L. And yeah, we added a recycler view. And now what we are going to do is we are going to create an adapter. So if you remember, we created an adapter for an affirmations app. We also had adapters for our words app. And now we are going to create an adapter. So inside our overview package, I'm going to create a new Kotlin class called photo grid adapter. And it is going to be inherited from list adapter. So make sure that this list adapter is androidx.recyclerview.widget, that thing, not android.widget list adapter. And inside that, we are going to pass the data class as Mars photo, and then we have to pass the view holder. We haven't defined the view holder yet, but we might get an error right now. So don't worry, we will fix that. I'm going to name this as Mars photo view holder. And we are going to have something called a diff callback. We will see what this is in a few minutes. Cool. If you remember, we had to implement some functions of this list adapter. So for that, what we are going to do here is just press Alt Enter, and we can implement the unimplemented members here. Select all and click on OK. We have on create view holder and on bind view holder here. We have to implement that. Now we are going to create the view holder class. For that, this is a nested class. This is same as that we did before. We are going to have this March photo view holder. March photo view holder class is going to accept the binding variable of type grid view item binding. It is going to inherit from type recycler view dot view holder. We are going to pass the binding dot root as the view. And inside this view holder, we are going to have a function for binding. So let's call this function bind. And we are going to accept a Mars photo object, which is our data class. We are going to set binding dot photo as March photo. And then we are going to add a line called binding dot execute pending bindings. So why are we doing this? So we should do this because if you notice here, binding dot photo, this photo is the thing that we defined here. If you see, we gave the variable name as photo, right? So this data is connected to this thing that we have over here. So when we are setting data for this photo, it will just automatically call the binding adapter for that we wrote inside our binding adapters class. It will pass this Mars photos URL to that Mars photos object to that, and it will load the image using Coil library. And all this happens because we have data binding. So we are just setting the data to this binding variable as the Mars photo that will be passed to this bind function. Then we should do this immediately because after we set the value for this photo variable, this should be executed immediately. So make sure that you don't miss out this line. This is important. And yeah, inside our own create view holder, what we are going to do is we are going to return this view holder, March photo view holder, and we are going to inflate grid item view binding dot inflate layout inflator dot from, and we are going to pass the context of parent dot context. Cool. So we just wrote on create view holder here, and inside our own bind view holder, we will have something called val March photos. March photo. It is going to be, we are going to get the item at this position. So this particular position. So we are getting the item from that. Now we are going to bind this to the holder. So that for that, what we are going to use is holder dot bind. So this bind is this bind function, and we are going to pass this March photo object. So this is what happens within on bind view holder. We are just getting March photo at that particular position, and we are binding this to the holder. And now we are going to have a companion object. We have seen companion object before. So we are going to define a companion object called diff callback, and it is going to be of type diffutil. So what is this diffutil? So diffutil is basically a thing used to identify the similarities between two data. So to check that whether both these things are same or both these things have same content. So it will be more clear when we actually do this thing. So what we are going to do this is diffutil.item callback, and it is going to be of type March photo. So we just want to check whether two photos are same or two photos have same content. So if we notice here, we have an error because we haven't implemented some members. For that, let's do that. Implement members and select all. There are two things here. Are items the same? Are contents the same? So when do we know that whether two photos are same, two items are same? The IDs should be same, right? So we are going to return old item. So there are two things, old item and new item here. We are comparing these two items in this. We are going to return old item dot ID is equal to new item dot ID. So this will return true if both the IDs are same, else it will return false. So we are just checking whether both the IDs are same. both the IDs are same, it means they are essentially the same items. So then we have something called are contents the same. So to check if the contents are same, we are going to return old item dot image source URL is equal to new item dot image source URL. So if the URLs are same, it means that the content of the images are going to be same. So that's why we are using a diff util here. And now we have set up the grid adapter, photo grid adapter. Now let's go to our binding adapters class and add one more binding adapter here. We're going to name this as list data, and we are going to give the name as bind recycler view. We're going to use this binding adapter for binding recycler view. We're going to accept a recycler view of type recycler view, then a list of March photo, which can be null. So we are going to call this data. And what we are going to do here is we are going to set the adapter of this as going to get the adapter of the recycler. We will set the adapter from the fragment itself, and we will get the adapter here. Okay, so this is going to be of type photo grid adapter, and then we are going to update the data set. So there is a function called adapter.submit list. So inside the submit list, we are going to pass this data that we got here. So when this binding function is called, it will update the adapter with the new data list. So yeah, that's what we do inside the bind recycler view thing. Let's get to this fragment overview, and we have to add this data to the recycler view. So since we are using data binding, we can directly use this. For that, we're going to have app list data. So this list data is the thing that we wrote here. This is going to be Viewmodel dot photos. So yeah, this is a list of March photos. So we are setting this list data. So since this is a live data, once retrofit gets the data from API, it will automatically observe for this and update the adapter. It will call the binding adapter and update the adapter with the new data that we have here. It will update the adapter with the new data that we have, so that the recycler view will be filled with the data that we got from internet. So right now what we are going to do is we are going to make a small add two lines inside our fragment class, because we have to set the adapter for recycler view. So for that, binding dot recycler view, binding dot photos grid. If you remember, the name was photos underscore grid. The ID was this. We're going to set the adapter as photo grid adapter. So this is the initial setting of adapter for recycler view. Then further, when the data changes, it will update inside our binding adapter. That is why we are getting the adapter here and then updating the list, because we have already set this adapter inside our fragment class. So that's why we are setting the adapter inside our fragment class. And yeah, let's try running this. Let's see what is happening. Okay, so we have a grid of photos here. If you scroll down, you see the whole photos arranged in a grid. So everything is working perfectly. We added a recycler view, we wrote an adapter, we wrote binding adapters so that we can access data from our XML file itself. So yeah, this is working. I hope it is clear to you. Inside a grid recycler view, you have populated it with images from internet. We called the API using retrofit, and we populated the image view with Coil library. We saw using live data and view model and used data binding to connect all these things. So yeah, this is the final thing that we were supposed to build. If you see, this was our target, so we have reached our destination. We will wait for some more time for you to catch up, and if you have any errors, let us know. So yeah, we will wait for some more time in the chats. Also, if you haven't joined this Telegram group yet, make sure that you join the Telegram group. We will be sharing the form and every other follow-up activities inside the Telegram group. I hope everyone will be part of this. Everyone is a part of this group now. If you haven't, join it now so that you don't miss out anything. We have the Telegram group link inside our chat section as well. Cool. I hope there are no doubts. We can wrap up. Cool. So thank you guys for joining in. So this was our third and final session of Android Study Jams. Thank you for joining in for all these three sessions, participating in this, all the activities, building a lot of apps. I hope you all learned something new. You are always encouraged to try out new things. You can always use this Telegram group to ask any of your doubts, any of the issues that you're facing. We will be there to help you out even after the program ends. You can always use this group to network with others and also clear any of your doubts, or even you can post your amazing projects in there. We will be really happy to see that. So yeah, I think it's a wrap. We can wrap for today. Thank you so much, guys. Thanks for joining for Android Study Jams this year with GDSC VIT.